Hello everyone. Today we are going to do chemistry HL paper 2, higher level paper 2, which was on 5th November 2024 in Indian subcontinent, and it's of 2 hours and 15 minutes, 90 marks paper. Last paper of the old course. The question number 1 says that alkanes are commonly occurring organic compounds, and the first four straight chain alkanes are gases at room temperature, and the boiling point of these straight chain alkanes are given to us. Number of carbon atom 1, 2, 3, 4, 5, 6, that's still hexane is given. And as we move from methane, which is CH4, towards ethane and C6H14, which is hexane, the boiling point goes on increasing. The first question is, explain why the boiling point increases from methane to propane. Methane, ethane, and this is propane. C3H8. This is propane, and the boiling point of propane is approximately 240 approximately. He's asking why the boiling point of methane increases. Now, as we know, the boiling point basically depends on van der Waals forces of attraction. Boiling point is directly proportional to van der Waals forces of attraction, that is intermolecular forces, and these intermolecular forces increases. Intermolecular forces are directly proportional to atomic masses or molecular masses. In this case, the molecules, I will write molecular masses. Intermolecular forces are directly proportional to molecular masses. And from methane CH4 to propane C3H8, the molar mass is increasing. Therefore, van der Waals force of attraction is increasing. Hence, boiling point will increase. Thus, boiling point of propane will be greater than methane. So the keywords in this answer should be boiling point directly proportional to van der Waals force, and methane has lower boiling point and propane has higher boiling point, higher molar mass, and thus higher boiling point. So we have to write propane has higher molar mass than methane, and the intermolecular forces are directly proportional to molar mass. Therefore, from methane to propane, as molar mass increases, boiling point will increase. So this is question number 1, part A. Question 1, part A, subpart 2. Explain why the volume occupied by sample of propane increases sharply when a sample is heated from 200 to 250 Kelvin. The temperature is increasing from 200 to 50 Kelvin at constant pressure. The boiling point is increasing. As we see this graph, the boiling is saying why the volume is increased. As we see the graph, the boiling point of propane is about 240 Kelvin. Now, when I'm increasing temperature from 200 to 240 Kelvin, what will happen? Methane is already a gas, and its boiling point is 250. We are increasing from 200 to 250 Kelvin. At 200 Kelvin, methane will be a liquid. At 240 Kelvin around, the methane converts from liquid to gaseous state. Thus, as temperature increases, we know kinetic energy of gas particle will goes on increasing. Kinetic energy of gas particles increases as we increase temperature. As temperature increases, so I will write temperature increases. What will happen? Kinetic energy of the gas particle increases. And when kinetic energy increases, the volume of gas also increases. This is as per Charles' law, which says that volume is directly proportional to temperature. Temperature increases, volume increases. This should be the answer. I think the keywords must be at 200 Kelvin, the methane is a liquid and its boiling point is 240 Kelvin. So when we increase temperature from 200 to 250, the state of methane changes from liquid to gas, and on increasing temperature, the kinetic energy increases. Therefore, the volume of the gas particles increases. When we increase kinetic energy, the gas particles moves away from each other. On increasing temperature, kinetic energy increases, and we can also add the gas particles moves away from each other. Moves away. These should be the keywords which should be present in this answer. It's a 2-mark question. The first, I think the marks will be for this. Temperature 200 Kelvin liquid and 240 Kelvin it is a gas, and second should be volume increase because kinetic energy increases. I think these two should be the answers of this question. For getting 1 mark, we should write the state changes from liquid to gas, and for second mark we should write temperature increases, kinetic energy gas particles increases, and volume of gas directly proportional to temperature. Thus temperature increases, volume occupied by the gas will increase. Question 1, A part, subpart 3. Calculate the volume in dm cube occupied by 6.45 grams of propane at 100 kilopascals and 15 degrees Celsius. Pressure is kilopascals and volume in dm cube, it will directly come if I put PV equals to nRT, and propane is C3H8. First of all, find temperature in Kelvin. 15 plus 273, that is equals to 288 Kelvin. Kelvin temperature in chemistry should always be in Kelvin. Whenever you calculate anything, you have to first convert degree Celsius to Kelvin. Now the second thing is MR of C3H8, that is equals to 12.01 into 3 plus 1.01 into 8, that comes out to be 44.11. Next, number of moles of C3H8. Number of moles of C3H8 is given mass of propane 6.45 upon 44.11, that comes out to be 0.146 moles. 0.146 mole. Putting the formula PV equals to nRT in the values of the given, and I have to find out V equals to nRT upon P. Putting the values, V equals to N is 0.146 into R is 8.314 into T 288 upon pressure 100. Pressure is in kilopascal, so I will get volume directly in dm cube. Therefore the answer for this is 3.496 dm cube, which is approximately equal to 3.5 dm cube. This is the answer for third part of question 1A. Fourth part, outline why the volume occupied by propane, he is asking volume occupied by propane at very high pressure is higher than the value calculated by PV equals to nRT, that is ideal conditions. Now when the pressure is high, the gas particles have a finite volume, which is as per which is against the postulates of gas theory, that is ideal kinetic theory of gases. According to the postulates of van der Waals, at high pressure when the gas molecules come closer to each other, when the gas molecules come closer to each other, when the gas molecules are closer to each other, they have a finite volume. The volume of the gas cannot be considered as negligible. They have a finite volume. As a result, the volume occupied by gas molecules, you have to write this language, volume occupied by the gas molecules becomes significant as compared to because they are now the finite volume, the volume occupied by the gas molecule becomes significant as compared to volume of the container. Okay, at high pressure when the gas molecules are closer to each other, the volume occupied by the gas molecule becomes significant as compared to volume of the container. Thus the total volume occupied by the gas occupied by the gas becomes greater than the volume predicted by ideal gas. Greater than volume predicted by ideal gas. That is the measured volume experimentally, hence the experimentally measured volume will be greater than as predicted by ideal gas, will be greater than PV equals to nRT as per ideal gas. Okay, what should be the keywords? The keywords here should be, as per me, the keyword should be the gas molecules have finite volume. At high pressure they have finite volume, and the volume occupied by gas molecule becomes significant. Hence, the total volume becomes greater. This should be the keywords. Okay. Question 1, part 4. Next question is question 1, part B. Ethane can be converted to chloroethane by reacting with chlorine gas in presence of UV light. He's talking about substitution reactions. What type of reaction? The name of the mechanism by which it occurs. So my answer should be free radical substitution reaction. Whenever they ask you what type of reaction, substitution, we have to always write free radical substitution. You should not write only substitution, because the specificity of the answer should be free radical. Although this question is asking the mechanism, so we will get 1 mark for writing complete mechanism, that is free radical, and the name of the reaction is substitution reaction. Okay. Next is question 1, part C. Chloroethane, is saying chloroethane can be converted to ethanol. Identify the reagent and the condition necessary. Chloroethane converted to ethanol, it can be done by chloroethane by nucleophilic substitution reactions. Nucleophilic substitution reaction, and the reagent required for this is aqueous, dilute, cold, NaOH or KOH. NaOH or KOH. Condition required is 60 degrees Celsius. That should be the conditions. The answer for this question is aqueous, dilute or cold, NaOH and KOH, 60 degrees Celsius. Reaction takes place by nucleophilic substitution. We all know it. Question 2 says alkenes are useful in industry, and part A is butanene containing sigma and pi bonds. There are sigma bonds and pi bonds. Identify the hybridization of the carbon atom labeled as A and B. This is carbon atom A and this is carbon atom B. A has a double bond, that A will be an sp2 hybridized carbon, and B is a single bond, and it will be sp3 hybridized carbon. Therefore, the answer for A is sp2 and for B is sp3. Next is describe how sigma and pi bonds are formed. Second part, how sigma and pi bonds are formed. Sigma bonds are the bonds formed due to head-to-head overlapping. Due to head-to-head overlapping of atomic orbitals. Head-to-head means along internuclear axis. You can also write along internuclear axis. Internuclear axis. So when the overlapping of the atomic orbitals, head-to-head or along internuclear axis, overlapping of atomic orbitals. Overlapping of atomic orbitals, that forms sigma bond. And the pi bond is formed due to sideways. Formed due to sideways or lateral overlapping of atomic orbitals. They are formed due to sideways or lateral overlapping, and pi bonds are formed, sigma bonds are formed due to head-to-head overlapping, and pi bonds are formed due to sideways overlapping, also called as perpendicular to internuclear axis. We can also write perpendicular to internuclear axis. Perpendicular, sideways can also be written internuclear axis. These two should be the keywords for the part 2. Now the B part of the question says butanene reacts with HBr to produce 2 structural isomers. We know it can form 2 isomers, and he's asking explain which of the 2 isomers is the major product. Okay, first the 2 isomers which butanene can form is butanene CH2CH, CH2CH3. If it reacts with HBr, it can form 2 isomers. Number 1 is CH3CHBr, CH2CH3, 2-bromobutane. The second one is CH2Br, CH2CH2CH3, 1-bromobutane. It is 2-bromobutane and 1-bromobutane. Out of this, 2-bromo and 1-bromobutane. These are the 2 possibility isomers. Now, out of this, 2-bromo is the major product. Why? Because the 2-bromo is formed when the pi bond of this but is broken down. When HBr attacks on butene, the pi electron clouds, they can move towards CH group or towards CH2 group. When the pi electron clouds move towards CH2 group or CH group, the first attacking species, which will be an electrophile, that is hydrogen ions, H plus ions, pi electron cloud is moving towards CH group. This CH2 is acquiring a positive charge and CH acquiring a negative charge. The first attacking species, which is your H plus ion electrophile, that will attack the CH, forming a 1 degree carbocation. Whereas when the pi electron cloud move towards CH2, the CH2 will acquire a negative charge, CH will acquire a positive charge, and CH2 CH3. The H plus will attack on CH2 group, forming a 2 degree carbocation, CH3 CH CH2 CH3. This is a 2 degree carbocation, it's a 1 degree carbocation. A 2 degree carbocation is more stable because of the presence of 2 electron donor groups. It is more stable, it has 2 electron donor groups as compared to 1 degree carbocation. Hence, the reaction will proceed towards through 2 degree, and the Br negative, the Br ion, will attack on the Br. Now the Br minus will attack on the CH and forming the product CH3 CH CH2 CH3, which is a 2-bromobutane. What should be the keyword? Keyword here should be the 2 degree is more stable due to the presence of 2 electron donor groups. Therefore, the reaction proceeds through this, and this will be the major product, whereas the minor product will be 1-bromobutane. 1-bromo will be minor product. Okay. Next part says explain the mechanism. Next part is explain the mechanism of formation of major product using curly arrows. Curly arrows shows electron transition, electron movements. So we'll take first but1ene CH2 double bond CH CH2 CH3, and this but1ene can show electron transition to 2 carbon atoms. The pi bond electron can go to CH or they can go to CH2. There are 2 possibilities. If the pi electron clouds goes to CH2, CH2 will get a negative charge and CH will get a positive charge. CH2 CH2 CH3, CH2 CH CH2 CH3, and this will get I am transferring it to negative charge this and positive this. Next, if the pi electron cloud goes to CH, then CH2 will have a positive charge, CH will have a negative charge, and CH2 CH3. These are the 2 possible electron transitions. Now, in case of the first one, the first attacking species, my electrophile H plus, and this H plus will attack. If I have to show the curly arrows, then I will write it again. CH2 CH CH2 CH3. If the electrophile H plus attacks this carbon, it will go to CH2 and form a 2 degree carbocation, CH3 CH CH2 CH3. It is a 2 degree carbocation, secondary carbocation. And this 2 degree carbocation has 2 electron donor groups. It has 2 electron donor groups. Therefore, 2 electron donor. And due to this, the intensity of positive charge will decrease. Positive charge density or intensity will decrease. Intensity decreases, making it more stable. Hence, it becomes more stable. Whereas, if we talk about the second possibility, which is CH2, when the electron cloud goes to CH, CH minus, CH2 plus, and CH2 CH3, if the electrophile H plus attacks, it will attack on the CH, forming a 1 degree carbocation, CH2 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 CH3. Now this is a 1 degree carbocation. 2 degree carbocation was this carbocation, and this is 1 degree carbocation. 1 degree carbocation. Now 1 degree carbocation has only 1 electron donor group, thus less stable. It is less stable. 1 electron donor Now this 1 degree carbocation has only one electron donor, thus it is less stable as compared to its positive charge dispersal will be less, positive charge dispersal less stable, lower dispersal of positive charge, dispersal of positive charge or intensity of positive will increase of positive charge. Hence, the reaction will not proceed or will proceed less through 1 degree carbocation. Whereas since 2 degree carbocation is more stable, now the attacking species Br minus, which is the second attacking species, that will attack this 2 degree carbocation, forming my final product, which is 2-bromobutane. Since a 2 degree carbocation is more stable, now the next attacking species Br minus will preferentially attack on this 2 degree carbocation, forming the 2-bromobutane as the major product. So why the 2-bromobutane has been formed? The answer is because of the stability of the carbocation. 2 degree carbocation is more stable, it has 2 electron donors, positive charge intensity decreases or dispersal of positive charge is more. I can also write dispersal of positive charge dispersal is more, therefore it is more stable, thus more stable. Okay, this is all about this question. You will get marks for the curly arrows shown from butane, H plus ions, as well as through bromobutane, through bromine also. Thus this will be the final answers. 2-bromobutane will be my major product. This is major product, and 1-bromopropane-butane will not be formed easily. 1 degree carbocation less stable. Okay, next third part is one of the structural isomer can exist a pair of enantiomer, that is optical isomer. State the name of the instrument which can be distinguished between enantiomers. We can distinguish enantiomers by the help of their optical activity, and optical activity is measured by polarimeter. The answer for this question is polarimeter, which measures optical activity, and the two enantiomers differs in optical activity. Therefore, we can distinguish between the two enantiomers by measuring their optical activity. One will rotate the plane of polarized light towards left hand side, other towards right hand side with same angles, and that can be measured by polarimeter.